So finishing off the notes for chapter 9, we went through the ladder of powers, which is when you've got data and it's not too badly bent, right? When it's badly bent, frequently you take the logarithm of either the response variable or the explanatory variable. And there's some comments on this about when possibly to use them. And, if nothing else works, you take the log of both of them. Okay? And as we said last week, figuring out which one is best can take a really long time. So on the AP exam, they don't typically ask this question. I may ask it on the quiz on this. And if you pick one and it doesn't work great, then just say, I picked this and it didn't work great. Okay? How do you know that it worked well? This is what Christina and I were talking about a minute ago. And this is straight out of the information that College Board sends out about the AP exam. So one of the things is that you have to be able to calculate a predicted response using a least squared regression line for a transformed data set. That's what you were doing in number 1, right? That was a transformed data set. So be able to calculate the predicted response. And then the other thing is that if you have done some sort of transformation of the data, here's how you know it's gotten better. If you've got increased randomness in the residual plots after transformation of the data, and or, it doesn't have to be both, movement of the R squared value closer to 1. Either one of those, or both, offer evidence that your transformed data is more closely linear than your original data. Now, it still may not be great yet, but that means it's gotten at least a little bit better. Okay? And you should know that there are various things you can do. You can use the natural logarithm. You can square. You can do various things. Notice that they pick out 2 in particular to talk about, but they say such as. So evaluating the natural logarithm of each value of the response variable, right? That's your output. Or squaring each value of the explanatory variable, that's your input. Those can be used to make transformed data sets, and then maybe more linear and formed than the untransformed data. In the end, that's what you really have to know. So you have to be able to predict. So use your calculator to help you make the prediction. You have to know that there are things you can do to make it better, but they're not going to see, you can see that they're not going to say, we're going to give you a set of data that isn't as straight as we'd like it to be, and you're going to have to pick which one is best. That's not what they're going to ask. Okay? They may ask you to pick something, right? Pick something and see what happens. Okay? And then you should be able to respond, this is better, because either R squared is closer to 1, or there's increased randomness in the residual plots. Or, hey, neither R squared is closer to 1, nor is the residual plot any more random than it was before. This didn't help. Or in some cases, this made it worse. Be able to say that. Okay? All right. Any questions about those? Okay, so that wraps up that unit, at least in terms of the notes.